腿软，顶起出汗头。
Let's wait a few more minutes before we start. Hello, interesting. Okay, good morning to everyone. This week we'll have two announcements to make. One is about quiz 3, is on next week, and then the other one is presentation. Okay, so for presentation, we encourage you to form groups. Okay, we allow 1 to 4 person, but we encourage you to form groups. So one group is a most 4 person, and each one of you have to present around 3 minutes. Okay, so you need to keep your content 3 minutes. If you are single soloing, then you need to go for 5 minutes. Okay, so we have put out the description of coursework in Moodle. Have you checked it out yet? What's the deadline? Good question. Very good question. So what's the deadline? So let's see. Huh? Yeah, it's next year because it's January. It is next year. Actually, it's in the last week. So what day is it? Let me see. So if you go to your Moodle, I put it at the last of the day. Friday. So last week, Friday. Okay, week 14, Friday. And you need to record it. Okay, you need to record it. And then either you upload to your SMUM drive. You know SMUM drive? There's a online storage for you from the schools. Or you upload to YouTube also can. You make it unlisted. As long as I can see it, share me the link. Okay? Yeah. So what's the topic you can pick? So if you go to Steward, right, a textbook, there's a lot of project topics like roller coaster, something like that. Okay, so you can choose those to answer. Or you just find other question that's related to calculus one, okay, using derivative or integral or even differential equation, which we will do it soon. Okay, and for various topics, you can choose from computer science, what you think, engineering, physics, bio, anyway. Okay. Yeah. So we will mark based on your presentation, okay, and then your slide, and then the correctness of your mathematics. But most importantly is your oral presentation. How confident you are with what you have spoken. Whether or not what you say is correct or wrong. Correct or not? Because in real life, people can speak confidently with wrong stuff. Then if you are confident, then you are convincing. Okay, unless you are knowledgeable. Otherwise, it's easily scammed. Do you know there's a scam company in Sansuria city actually get caught by police? Yeah, there's like 14 foreigner get caught. Yesterday, I just received a scam phone. Yeah, like acting as my colleague, want to like borrow money. So once he said he want to borrow money, exchange money, I just close it. Okay. Any question? So please have a read. If you have any question, you can ask me later. We will update it if there's any problem. Okay. How's the test? You think it's hard? Last week, I mean. You think it's hard? No? Some of you say no. A lot of say no. Okay, still okay. I only marked one question, so I can see improvement in the quiz, but also I see that some of you did really good in quiz, but not good in test. Okay, so maybe something to do with understanding. Yeah. Because if you just memorize, right, you can easily forget. But if you understand something, you won't forget. For example, if you look at a traffic light, do you know what to do? Traffic light. What to do? If you see green light, what do you do? If you see red light, what do you do? Yellow light, what do you do? Why can you remember? So you need to find some way, okay, to understand this material. Otherwise, you cannot remember. Okay, you need to understand. Okay, so understand involve making uh making logic. Okay, you know what's logic? You know what's logic? So basically, logic is the line that connects two points. Okay, the line is very important. If you just remember dot 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 answer, then you can't really uh, remember that many. Okay. So if you remember the line, okay, line can help you to connect to different places. Okay, so line is very important. Okay, sorry, I didn't show my line and dots. Okay, line and dots is very important. Okay, so line can help you go to different dots. And next week quiz is about quiz 5 and 6. Okay. 5 and 6, chapter 5 and 6. Same times, Monday, 3 o'clock, it will be released. And then last for 24 hours. Okay, so in that case, we'll start with chapter 7. 7. It's about more on integration, techniques on integration. So far we have learned the technique of integration was a substitution rule, okay, substitution rule. And then we learn a bunch of integration of volume, okay, not just rectangle, we have like circle, annulus, cylinder, so on, okay, up to 3D, three-dimensional. So now we're going to learn another way to do integration, which is integration by part. So what you need to remember is you want to integrate an integrand, okay, with respect to another derivative. Okay, with respect to another derivative. Then you just take uv, and so meaning you need to integrate this dv here to get uv, and then take away the symmetric form of this u dv here. So you swap the role of v and u. Okay, why it makes sense? Maybe we can play around with this integrand a little bit. So let's play around with it a bit. Actually, you can see that this comes from something that we know before. There's an extra dot here that's unnecessary. I think there's a typo here. This comma is important. Yeah. So maybe we can play around with this a bit, right? So we can move the minus term to the other side, like this. Okay. And then because integral is linear, so we can take them. Okay, but what's dv and du all the way from chapter 1? Okay, all the way from chapter 1, what's dv and du here? So dv is v prime of v prime. Let's say we put all the variable in dx like that. Du is equal to the u prime x dx. Do you remember the tangent, the length of the tangent distance, the differential? Okay, so if I put all these variable in, this will look like this. Okay, anyone can recognize what is this? Anyone can recognize? Recognize what is this? What? Product rule, right? So inside here is a product rule. Then inside here is a product rule. U v prime plus v u prime. Then this is a product rule. Okay, so on this side here, what do you get? You really get integration of the derivative of u. And but still remember how we write this? D of dx u v. But this is the definition of integral. Okay, definition of integral. The anti-derivative. Okay, so ux dx is the anti-derivative. This one is extra. Okay, so this integration by part comes from a product rule. Okay, so any questions so far? Any question? So you can do a definite integral version, okay, where you evaluate from A to B also. Okay, so this thing is the same as the previous thing. Okay, just that you integrate from A to B. Do a definite. Okay, any questions so far? Have anyone learned this before coming to university? Anyone learned this before? Integration by part? No, no. Indon, no. Other places, eh? Also no. Hmm? Weird. Why did I learn this? I learned this in A-level. Yeah, but anyway, it's a different test. Okay, if you don't learn it, it's okay. So you learn it now. So you learn it now. Let's try on one example. Okay, try and integrate this x cos x dx. Okay, so this is like integrating the product function here. Okay, so it is this kind of function that you want to consider using integration by part. Okay. So how do you set? There are few choices, right? Actually, there are two choices, right? Maybe let's try two choices. Let you see where you can fail so that you know how to get out, right? Okay, so what do you need to set here? So if you want to use this formula here, what you need to verify is you need to set u and dv. This is the two things you need to set. So we try to set these two things here. So let u equals to x, okay? And then dv is equals to cos x dx, and then, okay? Okay, so maybe we can simplify this notation a bit. We can, because we know that dv is v prime dx. So we just set v prime equals to cos x. Okay, everyone okay? Happy or not? Happy? If not happy, you need to say so that I can try and make you happy. Yes. What's wrong? Huh? You don't understand which part. You need to tell me which part so that I can explain more. Mm. Mm. Okay, so dv equals to v prime dx. This is what we learned in chapter 1. I think chapter 2 or chapter where? Chapter 2, I guess. The derivative part. Can you still remember? This is what you need to start with. Okay, you need to accept this first. If you don't accept this, you need to go to chapter 2. For now, you need to accept first. And you go back to chapter 2. Okay, so if you get this, is it okay that I write down this line here? Yes, okay. So because dx is the same, right? So v prime have to be cos x. Okay, that's the logic. Okay, so oh, how about let me write down the formula. I think the formula is still new to you, so that we know what we need. This formula here. Okay, so we identify u already. We identify dv by identify v prime. Okay, so we need to get what is u and v now. Sorry, what is du and v now? Because u already have it. Okay, we need to get what is v and okay. So what is v and du? Okay, how do you get v prime to v? One is derivative, one is antiderivative. So you integrate. Okay, so you integrate. So after you integrate, what do you get? You integrate cos x. What do you get? What do you get? Yes. Integrate cos x. What do you get? So it's not far from differentiating, right? The answer you get should be differentiate to cos. So what's the thing that differentiate to cos? Sine x, right? Okay, so you integrate sine cos x, you get sine x. But maybe you will ask me a question, why not plus a d? Okay, doesn't matter because later we're going to do integration again. So all the d will come out together. So here, just pick one antiderivative. Okay, so d is not very important here because later on it will appear together with the next integral. Okay, it will appear together. And then what do we need? We need du. Okay, to get du, we also just need to compute what is u prime is enough. Okay, so u prime is 1. Okay, so that du, same problems here, same logic that we get from dv here. Du will be u prime times dx, which is 1 times dx. Okay. So all together here, what do we get? So in this case, by integration by part, where if I integrate x cos x dx, okay, so maybe you can see it like that, is equals to uv, so x times sine x, minus integrate v, so sine x, du 1 times dx, so dx. Then I get sine x sine x minus integrate sine x, you get minus cos x, right? Okay, so minus cos x. And then plus a constant. Then all the constant will combine. Yeah. Any question at the step? Question? Feel free to ask them because this is new stuff, so it's okay to start slow a bit. Question? So far, so good. Question? Alicia, got question? I mean, like, you can, there's nothing to understand for now. It's just step. So, which step you cannot follow? Maybe you can ask. For now, it's just putting things on. Still okay, huh? Okay, good. Okay. Maybe you can try another method, right? How about if I let u equal to cos x, and then dv equals to x dx. So let's say v prime equals to x. Is this good or not? Okay, maybe we use this method. Is this good or not? Okay, so we get u prime is minus sine x, and then v becomes x squared over 2. All right. Okay, so let's try this. Is this good? Uh, so in this case, we swap the role of cos x and sin x, right? And then we will get uv. Uv is what? X squared over 2 cos x. Then minus integrate of what? v du. V is what? uv, and then v du. Okay, do you think this is good? Is this good? Can continue or not? Know how to integrate this guy here? Things get even harder, right? Okay, so this is the technique of bypass. So, okay, if you choose a different choice, maybe the question become harder. Okay, if you choose a good choice, then you can solve it easily already. Okay, so this is making choice here. Okay, so if you do a lot of questions, then you will know what choice to make. Okay. So can you notice what happened here? What's the difference here? What's the difference of making different choices? Can you see? One side, I decrease the power of the polynomial. So the polynomial disappear. On the other side, I integrate polynomial. The polynomial power increase. But the trigo function still stay there. So it haven't disappeared yet. So both of them didn't disappear. Both polynomial and the trigo doesn't disappear inside the integrate. Okay. So it's not very good. You understand? Understand? Okay. So there's a choice here to make so make a clever choice so that your calculation can stop quicker. Does it make sense? Okay. So I will comment here, even more complicated with this choice. Okay, makes sense. Any questions so far? Question? No? Okay, so I let you try one more question. So see what choice you make here. Can you see products here? There's only one function. One function means what? Ln x equals to ln x times 1. Okay, so see if you want to make the one u or make the one x v, sorry, v prime. Okay, try. I give you 2 minutes. Shouldn't be long on this question. So I give you 2 minutes. Okay, so what did you set? Junjie, what did you set? What's your U? You set U equals to 1. Okay. D prime or next. Okay, let's try this. So U prime, what do you get? 0. Okay. And then B, what do you get? How do you integrate log x? Do you know how to integrate log x? Just go back to the same question, right? Just go back to the same question. Right? U equal to log x. Yeah, so you see, if you pick the wrong choice, you go back to the question again. Okay, yeah, you go back to the question again. Okay, so let's try another one. So U equals to log x, and then B prime equals 1. Okay, so log x, you differentiate, what do you get? 1 over x. It's okay to put 1 over x because our region is 1 to 2. Because I think last time do we put absolute value here or here? Which way? Anyone remember this? Which way? This way? And forgot. Forgot. Go back and find it. So is it like this? Last time we proved this or not? Go and find it. Okay, and then v. So integrate x, you get integrate 1, you choose x. Okay. Okay. So let's use the formula. So let's recall the formula again. Integrate u dv equals to uv minus integrate v du. So it's swap the order. Okay, and then we find the sign. So by integration by part, maybe integrate from 1 to 2 of ln x dx. Okay. So now is the definite integral, right? So you need to evaluate everything. Okay. So uv, what is uv? So ln x times x. And from a to b, here is 1 to 2, minus integrate from 1 to 2 of v, so x du. So what's du here? 1 over x dx. So maybe I remind you again, in future we are not writing it anymore. So dv is equal to v prime dx. Okay, so v prime x dx. Okay, or yeah, like that first. And then the other one is du equals to u prime x dx. All right. So, so on the first term, we just evaluate ln 2 minus 1 times ln 1 is 0. Okay, minus the integral of 1. So this is the integral of 1. So integrate to x. 2 ln 2 minus 2 minus 1. Okay, we should get 2 ln 2 minus 1. Any question? Question so far? Okay, make sure you can follow these steps in notes in the lecture, so that you can learn more advanced stuff in the textbook question. Any questions so far? Oh, good. Okay, what time is it? 10:32. All right. Okay, let's try another one. Let's try this one. Okay, I give you maybe 1 minute. See if you can do it faster or not. Okay, maybe you need some tool here. I'll give you some tool. So the tool is integral of 1 over square root 1 minus 2 square du equals to sine minus 1. Okay, so what did you try? Maybe 一横 what did you do? 一横 Yeah, what did you try? Uh-huh. Sine x. Okay, sine inverse x. V. Mm-hmm. V or V prime? V prime equal to 1. X? Where did you get the x? 1, right? Okay, yeah. Okay, so we differentiate u prime. What do we get? 1 over square root 1 minus x squared. Okay, because sine inverse u is the empty derivative, so the derivative of it is the thing inside the integrand. And then v, you get x. So if you use integration by part, integrate sine inverse x dx, you get uv, so x times sine inverse x minus integrate of v du, x over square dx again. Can we integrate that quotient? Is there any way to integrate that quotient? You want to use by part again, or there's some other rule you can use? Okay, so one way to notice is like there's a square here, right? There's a degree 1 here, right? So what's the relation between square and degree 1? So you differentiate x squared, you get x. Okay, so first thing you should try is maybe substitution. Okay, maybe you can try substitution rule first. Okay, so let y equals to 1 minus x squared, so that dy you will get minus 2x dx. Okay, this one is substitution rule. Okay, so by substitution rule, we get that integral of x over square root 1 minus x squared dx is equals to uh, minus 1 over 2 integrate 1 over square root y. Okay, or maybe you can do rearrange first. So x dx will be equals to dy over minus 2. So that's where the minus 1 over 2 comes from. Right? X dx equals to minus 1 over 2. Okay, and then square root 1 over x squared here become square root 1. Make sense so far? Okay. All right. So integrating this is very simple, right? Because the power of this actually is y to the minus half. Okay, so integrate this is you plus 1 and then divide by the power. Okay, so you plus 1 and then divide by the power. So what do you get? Get minus square root y plus. Okay, so plus 1 become half. Then you half divide by half become 1. And you keep the minus. Okay, if you are not sure, then you differentiate this y to the half. Then you differentiate what you get. Differentiate exactly, you get half times y to the minus. Okay, so then you can put everything back to x. So minus square root of 1 minus x squared plus c. Okay, and then so hence integrate sine minus x dx is equals to sine x, sine inverse x, minus minus all become plus. So plus square root 1 minus x squared plus some other constant t. Okay, any questions so far? Question? For now, it's still early stage, so make sure you ask as many questions as possible if you are confused. Okay, what time is it? 10:19. Okay, if that's okay, then maybe we will skip 7.4. Okay, and then we will try and do 7.5. Okay, 7.4 left as an exercise. I mean, you do yourself. Okay, answer. So let's do this. X squared sine x dx. Okay, so if you use the logic that I gave you just now, right? Because if you differentiate or integrate sine x, it won't disappear. Okay, x squared can disappear when you differentiate. Okay, so first thing you might want to do is you set u equals to x squared and then v prime equals to sine x. Okay, so that after you differentiate u, you will reduce the power, and then the integral of v is just stay with trigo. So it is cos, right? Minus cos, right? Minus cos x. So that if you use the integration bypass u times v, okay, minus v d du. Okay, minus. Okay. So you can see that we successfully decrease the complication of your integral. And see or not? X squared become x only. Okay, so we reduce one level, but then can you see that in this part here we still need another by part? Okay, so that we can reduce the 2x even more. Okay, so keep with the triangle like what we see just now. Okay, so if we continue the step, maybe let's compute what it is first and then we can continue. So we need another bipart. Okay, so u equals to maybe 2x. You want 2x or you want x? Doesn't matter. About 2x. Okay. And then u prime equals to 2. And then b prime equals to cos x. And then b equals to um, sine x. Okay. So we need another, again, another integration. So plus uv, okay, so 2x times sine x minus v sine x du. Okay, okay, so this is a chant you need to remember. Maybe you can sing during your bath, in your bath. Okay, integral v u dv equals to uv minus integral of v dv. Okay, so this is the chant you need to remember. Okay, otherwise you can remember product rule and you can deduce from the spot. Okay, so integrate 2 sine x is easy, right? Okay, so what do you get? Uh, minus 2 cos x. Okay, so 2 cos x. Let's see. Okay, any questions so far? Any questions? So in this question, actually, we're using repeated application of integration method. Okay, so once is not enough, maybe we need to do twice, or even thrice, or even four, one, two. Okay, any questions so far? Okay, so maybe people ask me again, how do you write down the step? Huh? Okay, so what step is important here? So make sure you know what u you set, what v prime you set every time you do integration by part. Then that will be good enough. Any question so far? Question? No? Can follow? Okay. So one thing, I mean, few things you need to be aware after I mark your exam, right? First thing is you can follow what I say. Second thing is you need to execute yourself. Okay, because in the test I cannot tell you, oh, do this, do this, do this, right? So you need to like able to tell yourself what to do and then you do it. Correct or not? Okay. This is also what you do in your clubs, right? Or in your MPU, maybe. You need to do a project. Okay, you want to do what? And then you need to execute your idea. Okay. Because sometimes people will start at the last stage is I got idea, but I don't know how to do. Okay, so this is what you need to learn during your university student life. Okay. First, generate idea. Second, execute your idea. Okay, so this is what you need to repeat and learn during your 3 year or 4 years. 4 years or 3 years are your degree. 4 years, right? Okay, so in this 4 years you need to sharpen. Okay, sharpen your tools, sharpen your mind. Okay, question? Any questions so far? So far, so good. Okay, so you try this. I let you try. 2 minutes. So Well, please try in class, so that we can learn together. Okay. Okay, so what did you try? How about 相似? What did you try? Okay, so we said you equals to sin x. Okay, then b prime you mean b prime equals to ex. So if you differentiate sin x, you get cos x, obviously. If you integrate v, what do you get? Again, ex. Again, same thing. Sure. Okay, so let's do once. So let's see what happens here. Okay, let's do once u times v. So you get ex to the sin x. And then v, so minus integral of v du cos x and dx. Okay, so you realize that haven't finished yet. Maybe you try again. Did you try again? Did you do again? 相似 is not done yet. Did you continue to do integration by parts? Hmm? Instead of new u and new v prime again. So the same as in u will be trigo cos x. V prime is e to the x. Okay, so u prime in this time will get minus. Oh yeah, sure. Minus sin x. V will be ex again. Okay, so let's write it down. Minus uv, so ex cos x. Okay, and then minus integral of v du. So v is ex. Du is minus sin x. And let's rewrite it better. E to the x sin x. Seems like never ending, huh? Never ending, ah. Seems like never ending. Should we continue again? Huh? No? Why? Did I get my sign wrong or not? Is my sign okay? I think my sign here. Is it okay? My sign? Any sign problem here? Okay, so far. Okay, let's take it first. So what can we do next? Anything we can do here? Anyone realize that we go back to the starting point? We go back to the starting point. Okay. If we repeat again, then you will like repeat the same term coming up. Okay. So instead, we just combine the two terms. Correct or not? You get what I say? Because if I write it out in this way, maybe it's easier. Okay, so two sides have the same thing, right? B. So this term, if this becomes 0, I think there's a sign problem, right? What's the problem? Hmm. Shouldn't be cancelling out. Eh? If cancel out, then we get this thing equal to 0. Sorry? Second step, this step. Third step. Oh, second. Okay, yeah, sure. Second step. So where's the sign problem here? Huh? Oh, so here is a negative, right? Okay, but inside your formula there is another negative, right? Okay, so this is a very common mistake people will make. So I make a common mistake here. So this within this green bracket here is the formula of integration by part. There is a minus sign already. Okay. So minus minus plus minus here will be a minus. This part will be a minus. Okay. So in this case here, you can move this combine the two terms here, right? It's the same thing. It's the same term. Yeah, so instead, what you get is 2 times integral of ex sine x dx equals to ex sine x minus ex cos x, or maybe I just combine the sine the e to the x, factorize it. Okay, then once your original integral here, you just get your right hand side divided by 2. Okay, very clean answer. Does it make sense? Question? Any question? Feel free to ask. Question. Okay. So I just combine the two integral. So this second step here actually is very important. What if you swap the order of ex and cos x? You go back to the previous step again. Okay, you can. I welcome you to do experiment. Okay, if you don't continue this pattern here, instead you choose ex again, you choose cos x, then you go back to the same starting. Okay, it's useless. Okay. Or in the same series, you pick u to be ux and then v prime to be the trigo part. You also get this result. Does it make sense? So you swap the trigo and the exponential function. But if you like swap in within the same series of steps, then you will have trouble. Okay. So what I say is, how about if you try u equals to ex and then v prime equals sin x. Okay, on the other side, then you will try u equals to ex again, then v prime equals to I guess it's the cos x, I guess. Okay, so you can try this as well, you get the same answer. Okay, but you cannot like mix the step. Okay, you cannot mix the step. Otherwise, you will go back. Okay, maybe let me write down what I said. Warning. If you do u equals to ex, v prime equals to sin x, and then you do u equals to cos x, v prime equals to ex, will return nothing. I think this is what happened if I didn't remember wrong. Okay, you can try all the possibility. Okay, see what happens. Okay, it doesn't work. Okay, any questions so far? Question? No question? What time is it? 10:56. Okay. How about let's take a break from here. Let's break until 11:06. Mm, yeah. Better you write this is the thing. This is calculation. Yeah, you can calculate. Sorry. Yeah, okay. Yeah, both can, both can, both. You should continue this. Then this is your method is what I brought in the group. Proper one, yeah. No, if you use the blue part, you need to follow the blue. If you use the red part, you need to follow the red and blue. Yeah, you cannot mix. So it's the warning. You cannot mix. If you mix, then you go back to the thing. Okay, so let's take attendance for those are here. Yating, here not Yating. Yeah. Some fun. Got Quỳ Ye, yeah. Hồng Leo, Hồng Leo, Vua Hồng Leo. Xi He, yeah. Lơ Thiên, yep. 瑞阳，若石，诗曼，一南，玉涛，一泽。Oh, hey, come at the right time. 例文，例文 I think is good. 瑞言，okay. 泽汉，加来，加成功，加怡，yeah. 齐军，义清，俊逸，俊业 where is 俊业 OK. 相思，一林，yeah. 冰珍，yeah. 家谈 OK. Why you see so hard today? You sleep OK. Sleep oversleep. 浩云 yeah. 文琪，安详 yeah. 俊杰 yeah. 新阳 yeah. 万达 yeah. 心愿 yeah. 玉衡 yeah. 一田 yeah. 冰城 OK. 浩然 got Desmond. I didn't see Desmond. For me, 秋意 英介 Kopagani 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 okay. Arthur yes. Jose got Hisham Daniel yeah. Hashim good. Madia got Aaron yes. Brandon I think Brandon toilet yep. Felicia also toilet. Gunakanti Margaret oh yeah okay. Javed here, no? Didn't see. Gabriel, Gabriel, good. Jeffrey, yes. Purity, go. You go back, Ali. Okay. I just now call you, right? Didn't see you. Yeah. Yes. Okay. Yeah, correct so far. Yeah. Yeah. Wait. Not right. Why you start with why you didn't start with yeah, you should start with this question, right? UV, so U times V, so it's this thing. So this thing equals to this thing equals to U times V here, and then minus dV. So okay, so what's the relation about dV and V prime is dV equals to V prime dx. Okay, so here is V prime, here's dx. Okay, so this is the dV. Okay, yep. And then UV is this correct. Then here wrong, right? Because it's minus VDU. So V is this part here. See. So this is the problem. Actually, this is not V, this is V prime. And then this is V. Is this V?
That's what I did here.
Should be minus, right?
What I did.
Yeah, that's what you did here. I just asked you to like swap these two.
Oh.
It's not like, yeah, it's not make it V. It's to write V prime first. Because V prime is something that you assume. So you should put your assumption come first, then your calculation at the back.
Okay.
Make sense? So this one swap done. Yeah. It's not swapping the row of V. That's all. Yeah. Okay, so before we start, right, some of you haven't come when I make an announcement. So there's a presentation. So presentation that you need to submit in week 14. So you can start and form your groups now. Okay, so the format I put inside the Moodles, you scroll to the last presentation, you submit there later. Okay, so you need to form your groups. So where's the groups? Wait. Yeah. So at most 4 person, you can do single solo, but the length we require is 5 to 12 minutes, or at most 12 minutes. So if you are single alone, you do at most 5 minutes. Okay. Otherwise, if you do in group form, all of you would do about 3 minutes. Okay. So this is the discount for group presentation. Okay. So if you are solo, you could do more. You should do more. If not solo, then everyone will do 3 minutes. Okay, so maybe on this Friday, I will start asking you, okay, which group you are in. Okay, yeah, start Friday, we will start asking you which group you are in. And then by next week, you kind of need to decide your topics already, okay, because just 1 more month left. So by next week, you should decide your topics. By this week, try to set your group. Then either you want to go solo or you want to do it together. So we have a group offer here. So if you do in group, each one of you just need to do 3 minutes. Okay, if you do solo, you need to do 5 minutes. Okay. Any questions so far? Okay, so Friday, I will ask you which group you are in. Okay. Let's continue. Okay, let's continue with integration by parts. So I'll see what can it do for us. So for example, we can find the integral of sine to the nx dx. Okay, so this n here we didn't fix. This n could be 3, 4, 5, 100, even 1,000. Okay, this n could be random, but we're gonna find a formula for it. So meaning we want to write down this integral in the integral, okay, in terms of n. Okay, in terms of some function, that function will be in terms of n. Meaning you put an n into it, you get this function out of it. Okay. So since this example is listed under integration by part, right? Definitely we need to try integration by parts. Okay. So but what's the u we want to set? What's the v prime we're gonna set here? Okay, so this is the problem. Okay, so what's the u? What's the v prime we're gonna set? There's a lot of choice here, right? Because sine n to the x, right, is like you multiply n times sine x together. Multiply n times. So how do you split out the products? Okay, so well, we can try the easiest way. Okay, we can try the easiest way. So easiest way is let u equal to sine of n minus 1x. So we just pull out, okay, pull out one of the sine x. That's it. Okay. It seems enough. We can try first. So if you differentiate u, you will get n minus 1 times sine to the n minus 2x times cos x. This is the chain rule. Okay, dx. Should I put a dx? No, here. Okay, so how about v prime here? Integrate v, integrate sine x, we get minus cos x, like that. Okay, so far so good. So far, okay. Okay, then we'll do integration by part. So integrate sine and x dx, we have successfully like set it up by sine minus 1x times sine x dx, like that. Okay, so it's in the form of u dv. Okay, u dv, so which is equal to u v. Okay, which is equal to uv minus integral of v du. Okay, so du is kind of long. Is it that long? Yeah, it is that long. Okay, seems a bit scary. So let us just copy it. Very long. So here's another cos x here. So what we do here? Let's just simplify it a bit. So minus minus plus or plus one sine minus 2x plus. Okay. Oh, seems like I violate my rules, right? Seems like get more complicated because we got a sine x with some power, and then some more got cos. Previously don't have cos, now I have cos already. Okay. But do you remember that cos square x has some relation with sine square x? You still remember? Cos square x has a relation with sine square x. What's the relation? Sine square x plus cos square x equals to 1. Okay, so we can write this in terms of sine square x. Okay, so see whether it's helpful or not. So let's replace this. And this cos 1x plus n minus 1 of integral of sine n minus 2x times 1 minus sine square x. Okay. Okay. Right. Let's see. Okay. So then, what do we do next? So we get that minus cos x sine minus 1x equals to minus 1 times integral of sine of minus n minus 2x dx. And then we split out another term minus of n minus 1 of integral of sine of. So n minus 2x sine n minus 2x times sine 2x. So you add up the power, you go back to sine to the nx. Okay, can you see? Can see or not? Okay, so what can you see is your starting point appear again. The starting point appear again. So by the logic we had before, you can combine with the term on the left hand side. Okay, so maybe I write it in the horizontal form, it's easier to see. And how about I write it in this form? Perhaps it's easier to see now. I'm missing an angle. Okay. Okay, so what did you see? So there's a sine n, the sine to the nx on the left hand side. Also on this side, what am I doing? This is n. Okay, on the other side, we'll also get integral of sine to the nx dx. Okay. But here there's an n minus 1 multiple as a minus sign here. Okay, so if you move to the left hand side, what do you get? Plus n minus 1. So n minus 1 plus 1, you get n. Okay, so you get n. And so if you move to the other side, you get n times sine x dx equals to this bunch of things. Okay, but we just want to compute integral of sine to the nx, right? So let's throw the 1 over n to the other side. Okay, so then we are done here. Okay, so we are done here. So why are we done? Because we have successfully reduced this integral of this sine to the nx here to some integral with a smaller n. Okay, so in this case here, how do you compute integral of sine n minus 2x dx? You can make this n into n minus 2 and then repeat this formula. So this formula seems to be iterative, right? Infinitely many times. But think about this n here. This n is a finite n. Let's say this n is 6. Okay. If you go to this term, 6 minus 2 is 4. Then you apply this formula again. N is equal to 4. This term will become 4 minus 2. So it's 2. Then apply again. 2. N equals to 2. Then this term becomes 2 minus 2 is 0. Integral of 1 dx is x. Okay, so it will terminate because this n here is a finite. Okay, so this formula will terminate. Okay. Okay, makes sense so far. Okay, so reduction formula meaning you reduce the integral that involve n to some integral that's smaller n. So you reduce. Okay, then the question asks you to evaluate this, right? Okay, evaluate this integral with n equals to 8 and then with a finite limit here. Maybe I just show it to you. Don't do it. Don't bother to do it. Where is it? So here. Okay. And is it here? No, here. Here. Okay, so we just apply the formula. Okay, so you use the reduction formula, so it becomes 6 here. Okay, in the definite form becomes 6. And then you apply the formula with 6, n equals 6, so become 4, and then 2, and 1. And then you evaluate it. So it's a very nice sequence of fraction you get here. Okay, 7 over 8 times 5 over 6, 12 over 4, 1 over 2. So it's like odd on one side, even. Okay, so this fraction here drop out from this n minus 1 over n. Okay, because each n you reduce by an even number. Reduce by 2. So that's why you have a reduce by 2 pattern here. Okay, any question? You can try and do this yourself, but any question on the reduction formula? Question? What's the reduction formula? No? Okay, so far so good. Okay, let's continue then. Okay, let's continue. We'll do more integration. For now, we will use the trigonometric identity to help simplify the integral. Okay, so let's use trigo identity. For this type of question, I have a disclaimer or some warning to you. Maybe there are more than one way to do it. Okay, so I will just show it one way to you. If you think of another way, you can share it to us or tell us. Okay, so well, this is integral of sine to the 5x dx. Just now we have a reduction formula for this, right? So maybe you can use a reduction formula to do it, okay? Otherwise, we can use some trigo, okay, to simplify this integrand here. Okay, so what trigo we can use here? Just use the one that Purity mentioned just now. The easiest one you should know, okay? So let's try. So sine the 5x dx. Okay, hopefully we can write it as sine to the 4, or maybe I write it in this way. Is it more fancy? The fancy like this. Okay, well, what I can do was I can use 1 minus cos square x here to replace sine square x here. Can you see what I'm trying to do here? There's a cos here, there's a sine here. So what's the relation between cos and sine? They are derivative of each other. So what technique can use derivative? Okay, well, integration by part can, but easiest one we should opt for is substitution rules, right? Okay, maybe we can try substitution rule here. So there's a few things to substitute, right? Maybe you want to substitute 1 minus cos square x, or you want to substitute sine x. You can try, but my claim is you substitute cos x is enough, okay, for this case. And then you will get du equals to minus sine x dx. Okay, why do we do this? Actually, we will turn the whole thing into just polynomial. Okay, polynomial is easy to solve. So your end goal is, can I do the integral with polynomial or not? Okay, so now you can. Okay, so if I do this substitution, so let's rewrite it. Okay, if I rewrite it, I get 1 minus u squared and then everything squared. And then sine dx become minus du. Okay. So in this case here, why is this easy? Because I can just expand this quickly. 1 minus 2u squared plus u to the 4 du. Okay, so this is just polynomial, very easy. So what do I get? I get minus u plus 2 over 3u cubed plus u to the 5 over 5 plus c. Okay, and then I substitute all my u back. Okay, so far can follow? Can follow so far? Okay. Or do you have another method? Maybe you can share. Maybe you can try with different trigo here. So here we use that sine square x plus cos square x. Then maybe you can use more advanced one. Okay, makes sense. Question? Okay, maybe how about this one? Okay, I'll let you try this. I'll let you think about 2 minutes. See what trigo identity you can use. Maybe you can get a list. You can easily Google trigo identity. So there's a list. You can use all the double integral over some formula, difference formula, sum of angle, difference of angle. Yeah, please try. Even if you fail, doesn't matter. So you should identify why you fail, and then next time try to avoid it. Okay, so anyone try what method you say? I think yeah. You finish calculate? Okay, what did you try? What identity you use? Maybe tell us what identity you use first. Let's see how we use it. What's the trigo identity you use? Let's go with the okay, tell me the identity first. Like the yeah, the transformation you make. What's the trigo identity you use? What's the formula you use? For sine for x directly? You equate. Where did you get this identity from? Don't know. I use. What identity you use? Do you have a simple one, or you just have an identity for cos to the 4x? Do you have this whole thing here? Yeah, I calculate. How you calculate this? Yeah. What do you get? Okay, tell me what you get first.
Cosine 2x.
So 2x to 2 and then
2 is
outside.
no 1 2. Cosine 2 and 2.
Cosine to the 2x, right? Like this. Okay, that's it. Oh, everything to the power 2 again. And then, what do you say? What do you say? What do you mean outside? 2 times this thing? What? So is this correct or not? 2 cos to the power 2 2x? No, not correct. So cosine what? What do you get?
It equals to cosine 4x.
Cosine on 4x
Minus plus 1.
plus 1 inside or outside? Outside, okay. Everything plus 1 over 8. Okay, that's it.
Plus 1 over 4.
Everything again plus 1 over 4.
Yeah.
Okay, I think this is a bit too complicated because you need to do some step, right?
Yeah.
So I guess my trigo identity, what I meant is you should use like the double angle one. Okay, how about I search it for you? Okay, let me search it for you. So my trigo identity is something like this. I mean, you are okay to like to find formula here, but we try to keep it simple. Yeah, so maybe only from this kind of list, you should be able to do it already. Okay. Obviously, Jingjie also need these to help him to do, right? But we try to do it quicker, even quicker, even quicker. Yeah, only these, huh? What I meant by trigo identity. Okay, this is enough to help you. For the double angle one, you can derive from here, or let's see if there's any convenient one. Where's the double angle? Yeah, maybe this one is convenient. Okay, or you can read, you can look at the keyword. I guess keyword has a list of trigo identity, right? And so those are the things should be enough for you to work out. Okay, for example, this list. Okay, there's a double angle, there's a sum, okay. So well, I mean, if you can justify this step here is fine, but we can do even faster one. Okay, without knowing the whole form here. Yeah, this is faster. You think this step is faster? Very fast. You think very fast? Okay. I don't know. You can try. Okay. So if we don't get this whole form here, let's say if you don't get this whole form, so maybe you can try this. Jingjie suggests very fast, so you should try. So let's part. What do you mean? Wait, you mean there's another term or okay, another term cosine 2x. Oh, then this is the thing we're gonna get later. Yeah, this is the same method actually. Yeah, same method we're gonna get later. But actually it's the same then. So then this means so this step 1, step 2 is the same. Actually you get the same thing again. So actually what I use is just cos 2x equals to 2 cos square x minus 1. Okay, just use this repeatedly. Okay, so how do you use this? So you see that we have cos to the power 4, right? There's a cos to the square inside here. So meaning what? If you rearrange this, okay, if you rearrange this, you are just taking the right hand side to the square. Okay, so then cut down this the grand integral. Then you are actually integrating cos 2x plus 1 over 2 everything to the square dx. Okay, then you expand this. Okay. Yeah, I think it's what Jingqie get, right? Almost, not yet. Okay. So you need to apply another pi for cos square dx. Of course, cos square 2x. Okay, so you get 1 over 4 times integral of 1 dx plus integral 2 cos 2x dx. Okay, plus 1 over 4 of applying the formula again. Okay. Bit weird. I think it's not. Okay, and then you just continue to compute. Okay, so why is this useful here? Why do we prefer the power to go into x here? Because we can use substitution. Okay, we can use substitution to make this 2x, 4x become one variable u, for example. Okay, so let's try it. Okay, let's try it. Okay, what's going on here? Yeah, something wrong with my calculation. Never mind, let's do here. So for the first part, we just get over 4, right? And then for the second part, we need to do substitution now. Here, 1 over 2. Yes, we get cos 4x 1 dx. Oh, yeah, right. Okay, so that's another 1 dx popping up. Okay, so that's why. Okay, so maybe we can combine this. Is it okay that I combine these terms and this term together? Huh? Yeah, question? Any question? No? Okay. So then for the rest, we will use substitution. Okay, so we can set u equals to 2x and then du equals to 2 dx. Okay. Another one we'll set v equals to 4x and then dv equals to 4 dx. Okay, so we'll do this. Plus the rate of cos u, and then you get du over u, 2, sorry, and then the other one we get 1 over 8, and then cos b, and then dv over 4. Yeah. Okay, so then all together we get 3 over 8x plus 1 over 4 sine u, and then plus 1 over 32 of sine, and plus the constant. So all together we get 1 over 4 sine 2x plus 1 over 32 sine 10x. Okay. Okay, any question? Okay, so instead of integrating the power, we'll prefer to integrate sine to a multiple of x because we can do substitution. We can do substitution. After substitution, you are just integrating a normal trivial sine or cos function. Okay, makes sense? This is the trick when we want to try to integrate the power of trigo. Okay. So we use the double angle formula. Okay, so we use the double angle formula to push the power down. And we push the power down into the period. Okay, any question? Because inside the period we can do substitution. Question? No? Okay. All right. Ooh, so what should we do next? Should we do next? Let's continue. 7.10. How about 7.10 here? Is this obvious what you should do? Is this obvious what you should do? I mean, you can see what do you want to do? Actually, you can do this question without trigger identity. You just set u equals to cos x, and then du equals to minus sin x dx. Oh, actually, you use it. You use it. Yeah. Okay. So let's do this. Yeah, let's try this. So you can try whatever you want, but let me try one way. That's useful. Let u equals to cos x, okay, and then du will be equals to minus sin x dx. Yeah, so if I write like this, I think it's clear that I want to do substitution, right? So if we do substitution, what happened here is I turn the denominator become u to the power 4, and I eaten, okay, I eaten one of the sin x, so there's a sin square x here. Okay. So there's a mix between function in x and u, right? This is not good because we want to do substitution rule. Okay. But my claim is you can make sine square x into something is in u. Is it possible or not? Huh? Jose, is it possible? Sorry? Something in u. Okay, good. So we know that. So there's a trigger identity again. Same trigger identity, very simple one is cos square x plus sine square x equals to 1. But we know that cos square, we know that cos x is u, right? Okay, so the first term here becomes u squared. Okay, so in this case here, what do we see? Sine square x become 1 minus u squared. Okay, so it's something in u. So everything is in u. So very good. And then this thing you should be able to integrate, right? Because it's just a polynomial. Like that. Okay, you should be able to finish it. Or maybe should I write this? It's easier. U to the minus 4 and u to the minus 2. Easier. Question? Any question? Maybe I can quickly compute it. So here I get 1 over 3 of cos cube x minus 1 over cos. Okay, so this is the final form. After you substitute back your u. Again, because after integration, your power plus 1 plus 1. So minus 4 plus 1 becomes 3. Minus 2 plus 1 becomes minus 1. Yeah. Question? Any question? So far? So good. 40 question. Okay. How about I let you try this 2 minutes? Okay. See what identity you can try. So this here a bit complicated. Sine got square, cos also got power of 4. This is for your information. I think this chapter is a bit dry. You know what the meaning of dry? It's just a bunch of calculations. Okay, so this chapter is a bunch of calculation. You just use formula, calculate, formula, calculate. Not many meaning inside there. So it's a bit dry. Okay. What did you try? Anyone successful calculate this? Did you try any identity? Seems like this question is a bit long, at least my method. Not sure if there's a shorter one. Okay, so we will use the same logic. Okay, we try to bring the power into our period. Okay, into the x. Okay, so what can we use here? There are few identity to do this. Check. Okay, let's see what I do. Let's see what I do. Let's see what I do. Okay. The two things I will use first is so let's write down the trigo identity. Maybe identities. I use two of them. So one of them is sine 2x equals to 2 sine x cos x. And then the other one is cos square x is the one that we used before, equals to cos 2x plus 1. Okay, so let's see how I combine these two usage here. So you notice that you have 2 sine x cos x, okay, because you have square of them at least. So what I do was I combine it, become sine to the square 2x. Okay. So I left with cos x dx, right? Okay, but remember there's a scalar coming from 2, right? And then now you see we reduce power of 4 become 2 already. Okay, we reduce the power. Okay, we will reduce more. Okay, we will reduce even more. Okay, so let's reduce the cos square one first. So let's reduce cos square. So become cos 2x plus 1 dx like that. Okay, then what I get is 1 over 8 of sine square 2x cos x dx plus 1 over 8 of sine square x dx like that. Okay, I think this is enough for us to continue. Okay, we don't need to do any more trigo substitution from here. Okay, so what I'm going to do is, so our goal is like, if we can make it a polynomial, then it will be good. Okay, so how to see it as a polynomial? What if I substitute sine x to x to some variable? Okay, so let's do substitution. and u equals to sine 2x immediately. And what is du? So du is 2 cos x dx. Do the chain rule, get 2 cos x dx. Then any else I need to do? For now, we will do this first, and then you will see what's happening soon. Okay. Right. Maybe there's one more we need to do. This is for the first one. Can we make the second one easier first? Because if you see this substitution, right, this substitution won't work for the second term. Why? Because you don't have this cos 2x. But the first term is good because we have a cos 2x. Okay, so this term have to treat it separately. So this term here, we will use trigo substitution to reduce the power. So use sine square x equals to 1 minus cos 2x over 2. Then use this one. So in this case here, this will be integrating 1 minus cos 2x over 2. It's like that. Also, altogether, I think we use three trigo identity to reduce the power. Okay. In that case, should I continue or can you continue? Can you try and continue yourself? Do you know how to continue? So this term here, I will use substitution. Okay. Sine 2x. Okay. Yeah, this line is missing 2 here. Sine 2x. So equals to 1 over 8 integrating u squared and then du over 2 like that. Okay, substitution. And then this one, integrating 1 over 2 is fine, right? Okay, but how about integrating cos 2x here? You also do substitution. Okay, substitute your 2x. Yeah. Did I apply the formula wrong? I think I did because this is sine square 2x, right? So there's sine square x, so you need to have a 4x. And so actually this is the 4. Okay, so yeah, do another substitution with maybe w equals to 4x and EW equals to 4. Okay, two substitution. Okay, try and do this. Okay, any question so far? Know how to continue? You can continue yourself and then check solution with me. Question? Any question so far? Already got question? No. Okay. Yeah. Okay, try finish this. You can check solution with me, and then on Friday we'll continue with trigo identity that involve product of sine and cos with different period, and then we will compute something related to Fourier series, which you're gonna learn next sem. Okay, so see you on Friday.